Hello everyone, myself Sravanthi, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is dependency graph. So here we are going to discuss what is dependency graph with an example. So what is dependency graph? So dependency graph mainly tells us that the flow of information among the attributes in a parse tree. So nothing but here we are going to construct the parse tree and it tells us which statement should be executed first, that all the things will be represented over here. So nothing but it represents the flow of information. Which statement should be executed first, that will be told here. So among the attributes in a parse tree. So dependency graphs are useful for determining evaluation order for attributes in a parse tree. Okay, so it is mainly used for evaluating order for attributes. Which statement should be executed first, it tells us here. While an annotated parse tree shows the values of attributes, a dependency graph determines how these values can be computed. Here, it tells us that annotated parse tree is nothing but it is showing me the values of attributes, how it should be executed. But coming to the dependency graph, it determines how those values can be computed. It tells us that how these values can be computed. So here we are going to have the expression dependency graph. So 5 plus 3 into 4. So we are going to evaluate, or we are going to show how it is going to be evaluated. So by using this dependency graph, E produces E plus T. E produces E plus T. Why? Because in the production rules, the start symbol I am having is E. So the given expression is 5 plus 3 into 4. So first one is E is there. So E can be reduced to T. E can be reduced to T, or E can be reduced to E plus T. But I am having is 5 plus 3 into 4. 5 plus 3 into 4. So let me take the second production, that is nothing but E produces T. E produces T. So T is nothing but I am having here is T. There are two productions are there. T produces T star F. T produces F. So there is no star here. I am going to take, we are going to take T star, T produces F. T produces F. T produces F. So the next one, what we are going to hear, F produces digit. F produces digit. So the next one we are having is plus and T. So digit is nothing but 5 plus is completed. 5 plus is completed. So the next one I am having is multiplication operator is there. So here I have T is there. So T, there are two productions are there. T produces T star F and T produces F. Which one we can take is this T produces T star F. So T produces T star F. T produces T star F. So comes here and what we are having T. So T is nothing but there are two productions T star F and F. These are the two productions are there. The first production I cannot take. Why? Because 5 plus 3 into 4. Already multiplication operator I got. So I can take is F. F. F produces digit. F produces digit. So the next one I am having is F. F is nothing but directly I can take it as digit. Directly I can take it as digit. So here what I am going to have, we are going to evaluate. Here it is nothing but to construct the dependency graph. We are going to construct the parse tree and we are also using the values for these attributes. Okay, so here digit is there. Digit dot lex val. Digit dot lex val. So what we are going to have, it is nothing but 5. Digit dot lex val is nothing but 5. So plus what I am having here, digit dot lex val is equal to 3. Here digit dot lex val is equal to 4. Digit dot lex val is equal to 4. 5 plus 3 into 4. 5 plus 3 into 4. So what it does, it comes here, the dependency graph also, it tells us which statement should be executed first. So it comes here, top to bottom, it evaluates top to bottom, left to right, it comes here. So digit dot lex val is there. So this is the first statement, it is going to be executed. It comes here, F dot val. So what is the semantic rule I am having? F dot val is equal to what? Digit dot lex val is nothing but digit dot lex val is 5. Digit dot lex val is 5. F dot val is nothing but 5. So this statement is executed second. This statement is, the first statement executed is digit dot lex val is equal to 5. Then after it comes here, F dot val is nothing but digit dot lex val. So this is the second statement it is evaluated. It goes here. What I am having? T produces F. T produces F, right? So the semantic rule I am having is T dot val is equal to F dot val. F dot val value is 5. So this is the third statement executed. Third statement. it goes for the backtracking. What I am having here, E produces T, right? E produces T, nothing but E dot val is equal to T dot val. T dot val value is 5. So this is the fourth statement executed. It comes here plus no action. It comes here, and here I am having digit dot lex val equal to 3. So this is the fifth statement executed. So the next, it goes backtracking. It goes to the backtracking. F dot val. So F produces digit, right? F dot val is equal to digit dot lex val. So nothing but is equal to 3. It comes here. What I am having here, T produces F. T produces F is nothing but T dot val equal to F dot val. T dot val, F dot val is 3. So fifth statement executed, sixth statement executed, seventh statement it executed. So it is multiplication, no action, nothing. So it comes here, digit dot lex val equal to 4. So nothing but here seventh statement. This is the eighth statement executed. So next it comes here, F dot val is equal to digit dot lex val is nothing but 4. It comes here. Next here I am having is T produces T star F. Nothing but T dot val is equal to what I am having. This is the ninth statement. T dot val is equal to 3 and F dot val is equal to 4. So 3 into 4 is nothing but 12. So this is the 10th statement executed. 10th statement, and it comes here. What I am having, E produces E plus T. So E plus T, nothing but E dot val is equal to, E dot val is 5 and T dot val is 12. So 5 plus 12 is nothing but 17. So this is the 11th statement. It is executed. So it tells us, the dependency graph tells us that the flow, how the statements are going to be executed. We construct the parse tree. Then afterwards, we are going to show the evaluation order of our attributes, how they are executed, which statement is going to be evaluated first. So it is useful for determining evaluation order for attributes in a parse tree. Okay, so this is nothing but, so these 11 steps are taken to complete or to evaluate this 5 plus 3 into 4, and the resultant value or the output we are going to get is 17. So the first statement, as it is parse tree we are going to construct, the parse tree execution or calculation will be done from top to bottom, left to right. Evaluation will be done from top to bottom, left to right. First the left statements will be executed, then the right statements will be executed. So the leaf nodes are executed, then and finally the final value is executed. So we are going to construct the parse tree, and we are going to use the annotated parse tree also to evaluate or to write the values for the attributes by using these production rules, semantic rules. So this is about the dependency graph. The dependency graph tells us that how the flow of program or how the flow of attributes are executed in a parse tree. It shows us the flow of execution, which statement should be executed first. It tells us. Thank you.